In question 1, a curve is such that dy dx is equals to 8 upon square root of 4x plus 1. The point 2, 5 lies on the curve. We have to find the equation of the curve. Now to find the equation, we'll have to integrate the expression for dy dx. So in the first step, we can write dy dx is equals to 8 into 4x plus 1 to the power minus 1 upon 2. Now taking dx on the other side, we'll get dy will be equals to 8 into 4x plus 1 to the power minus 1 upon 2 dx. Now adding the integral sign to both the sides. So integrating dy will get y. So integrating dy will get y equals to 8 into 4x plus 1. We'll increase the power minus 1 upon 2 by 1. So that will become 1 upon 2 and divide by the new power, which is 1 upon 2, and also multiplied by derivative of 4x plus 1, which is 4, and then add a constant. Simplifying this, we'll get 8 divided by 2, which is 4. So this will become 4 into 4x plus 1 to the power 1 upon 2 plus c. Now to find the value of c, we already have a point on the curve, which is 2, 5. So substituting 2 and 5 into the equation, in place of y, we'll substitute 5. So this will become 5 equals to 4 into, and x value is 2. So this will become 4 into 2 plus 1 to the power 1 upon 2 plus c. So this will be 5 is equals to 4 into, this will be the square root of 9. So this will become 3 plus c. 4 times 3 is 12. So c will be 5 minus 12, which is minus 7. Once we have the value of c, which is minus 7, now we can write the final equation as y equals to, so the equation was y equals to 4 into 4x plus 1. So that will become 4 into 4x plus 1 to the power 1 upon 2 minus 7. In question 2, in part 1, we have to express the equation sine 2x plus 3 cos 2x equals to 3 sine 2x minus cos 2x in the form tan 2x equals to k, where k is a constant. So in the first step, we can just simply expand the equation, and in place of sine 2x and cos 2x, I will just use s and c. So this will become sine plus 3 cos 2x will be equals to 3 sine 2x minus 3 cos 2x. Taking cos on the left hand side, so this will become 3 cos plus 3 cos, and this will be 3 sine minus sine. So we'll get 2 sine is equals to 6 cos. Simplifying this, taking the cos on the right hand side, this will become sine upon cos is equals to 6 upon 2. As sine upon cos is tan x, so we can write tan 2x will be equals to 3. So the value of k will be equals to 3. Now in part 2, we have to solve the equation for minus 90 to 90 degrees. Now we already have tan 2x is equals to 3. So in the first step, we'll find the basic angle by taking tan inverse of minus 3. So as tan 2x is equals to 3, in the first step, we will find the basic angle by finding tan inverse of 3. So tan inverse of 3, when we substitute this in the calculator, that is equals to 71.56. So we'll be making 71.56 in the positive quadrants of tan. Now, tan is positive in the first and the third quadrant. So we will make 71.56 in the first quadrant and 71.56 in the third quadrant. Now, as the range is from minus 90 to 90, the first angle we can take is from the positive x-axis anti-clockwise. So 2x will be equals to 71.56. And as we have a range from minus 90, so for the second angle, we can take it from the positive x-axis clockwise. So this will become 180 minus 71.56, but this angle will be taken in negative as it has been taken clockwise. So this will be minus 108.43. To find x, we will divide both of the angles by 2. So 108.43 divided by 2 will be 54 minus 54.2 degrees, and 71.56 divided by 2 will be equal to 35.78, which we can simplify it to write it as 35.8 degrees. In question 3, a curve has equation y equals to 2x square minus 6x plus 5. In part 1, we have to find the set of values of x for which y is greater than 13. So in the first step, y equals to 2x square minus 6x plus 5. So we'll write 2x square minus 6x plus 5 as greater than 13. taking 13 on the left-hand side, so that will be plus 5 minus 13. So 5 minus 13 will become a minus 8 greater than 0. Simplifying this, we'll get x squared minus 3x minus 4 as greater than 0. Factorizing this will become x minus 4 and x plus 1 as greater than 0. Now to give the correct inequality sign, we can make a quadratic curve. So this point will be x equals to 4 and this point will be x equals to minus 1. As this has to be greater than 0, so we will have to move toward the right from x equals to 4 and toward the left from x equals to minus 1 to have a value of y which is greater than 0. So x will be greater than 4 and x will be less than minus 1. In part 2, it says find the constant value of the constant for which the line y equals to 2x plus k is a tangent to the curve. Now, the equation of the line is 2x squared minus 6x plus 5, and the equation of the line is 2x plus k. As we have an unknown constant, we'll have to use a discriminant b squared minus 4ac. And as it is a tangent, which means there is only one point of intersection, that means that b squared minus 4ac will be equal to 0. So in the first step, we'll equate the two equations. This will become 2x squared minus 6x plus 5. The equation of the curve equals to 2x plus k, which is the equation of the line. Simplifying this, we'll get 2x squared minus 6x minus 2x plus 5 minus k equals to 0. This will become 2x squared minus 8x plus 5 minus k equals to 0. So the coefficient of x squared is 2, so a will be 2. The coefficient of x is minus 8, so b will be minus 8, and the constant term is 5 minus k. Now substituting this in b squared minus 4ac, so b squared will be minus 8 squared minus 4 into 2 into 5 minus k equals to 0. Expanding, we'll get minus 8 whole square, that will be 64. 4 times 2 is 8 and 8 times 5 will be 40. So this will become 40 and minus 4 times 2 times minus k will become a plus 8k. So 64 minus 40 will be 24 plus 8k equals to 0. Taking 24 on the other side, this will be 8k equals to minus 24. So the value of k will be equals to minus 3. In question 4, it says that in the expansion of 3 minus 2x into 1 plus x upon 2 to the power n, the coefficient of x is 7. We have to find the value of the constant n and hence find the coefficient of x squared. Now, to find the coefficient of x in this expansion, so first we'll expand 1 plus x upon 2 to the power n. So the expansion formula is for 1 plus b to the power n, it is 1 plus nc1 b power 1 plus nc2 b power 2 and so on. So expanding this, we'll get 1 plus nc1. So that will be nc1 and b is x upon 2. So that will be x upon 2. And as we just need the coefficient of x, so we'll just expand it up till here. Now nc1 is equals to n. So we can simplify to write it as 1 plus nx upon 2. Now multiplying it by 3 minus 2x. So we'll get 3 minus 2x multiplied by 1 plus nx upon 2. Now to get a term in x, we'll multiply 3 by nx upon 2 and minus 2x by 1. So this will become 3nx upon 2 minus 2x, and that will be equals to the coefficient of x is given as 7. So that will be equals to 7x. Taking x common on the left hand side, we will get 3n upon 2 minus 2 is equals to 7x. X and x will cancel out. So 3n upon 2 will be equals to 3n upon 2 will be equals to 7 plus 2, which is 9. 9 times 2, so that will be equals to 18, and the value of n will be equals to 6. Once we have the value of n, now we have to find the coefficient of x squared. Now, so the expansion was 3 plus 2x. So it was 3 minus 2x into 1 plus x upon 2 to the power of 6. So we already have the expansion of 1 plus x upon 2 till the second term. As we have to find the coefficient of x squared, so we'll include the third term as well, which is nc2b power 2. So this was 1 plus, so n is 6, so this was 1 plus 6x upon 2. So we can just expand the expression again and write it as 3 minus 2x, and this will become 1 plus 6c1 x upon 2 to the power 1 plus 6c2 x upon 2 to the power 2. Simplifying, we'll get 3 minus 2x into 1 plus, so 6c1 is 6, 6x upon 2 will become a 3x plus 6c2. So if we substitute 6c2 in the calculator, that will become a 15. So that will be 15x squared upon 4. So 3 minus 2x, now when we're expanding, we need the term in x squared. So multiplying 2x by 3x, we'll get a term in x squared. So that will be minus 6x squared. And multiplying 3 by 15x squared upon 4. So that will be equals to plus 45x squared upon 4. Now simplifying this, so this will also be minus 6x squared. So this will become minus 24x squared plus 45x squared upon 4. Minus 24 plus 45 is equals to positive 21. So the coefficient of x squared will be 21 upon 4. In question 5, the line x upon a plus y upon b equals to 1, where a and b are constants, intersect the x-axis and y-axis at points a and b. The midpoint of AB lies on the line 2x plus y equals to 10, and the distance AB is equals to 10. We have to find the values of a and b. Now, as a lies on the x-axis, so it will have coordinates x comma 0, and it will have a b coordinate 0 comma y. Substituting this in the equation of the line, so substituting y equals to 0, we'll get x upon a equals to 1. So the x coordinate will be equals to a, and substituting x equals to 0, so that will be 0 upon a plus y upon b. So y upon b will be equals to 1, and the y coordinate will be equals to b. So a will have coordinates a comma 0, and b will have coordinates 0 comma b. Now, as the midpoint of AB lies on the line 2x plus y equals to 10, so in the first step, finding the midpoint of AB, so that will be x1 plus x2 upon 2, which will be a plus 0 upon 2, comma 0 plus b upon 2. So the midpoint will be a upon 2 and b upon 2. Now, as it lies on the line 2x plus y equals to 10, so we can substitute the values of x and y into the equation 2x plus y equals to 10. So as the midpoint lies on the line 2x plus y equals to 10, in place of x, we can substitute a upon 2. And in place of y, we can substitute b upon 2 equals to 10. Cancelling 2 and 2, we'll get an equation a plus b upon 2 equals to 10. We can take the LCM and write it as 2a plus b will be equals to 20. So this will be the first equation. Now it also says that the distance AB equals to 10. So applying the distance formula to points A and B. So for the distance AB, finding the square root of x2 minus x1 whole squared. So x2 is 0. So that will be 0 minus a whole squared plus y2 minus y1 will be b minus 0 whole squared. Simplifying this, we will get square root of a squared plus b squared, and the distance is equals to 10. We can take the whole square of both the sides and write it as a squared plus b squared will be equals to 100. So this is our second equation. Now, solving the two equations simultaneously, we can say from the first equation that b will be equals to 20 minus 2a. So substituting this in place of b in equation 2, we will get a squared plus 20 minus 2a whole squared equals to 100. Expanding this will become a squared plus 400 minus, so 20 times 2 is 40, 40 times 2 will become 80a plus 4a squared equals to 100. So a squared plus 4a squared will become 5a squared. This is minus 80a, and 400 minus 100 will become, so that will become a plus 300 equals to 0. Dividing the whole equation by 5, so 5a squared divided by 5 will become a squared. 80 divided by 5 is 16, so that will become 16a plus, and 300 divided by 5 is 60, so that will become a plus 60 equals to 0. Now factorizing this, we'll get the values of a as, so this will become a minus 10 and a minus 6 equals to 0. So the values of 10 will be a equals to 10 and a equals to 6. Once we have the value of a, we can find the value of b. Now, if I substitute a equals to 10 into the, as the value of b is equals to 20 minus 2a. Substituting a equals to 10, this will become 2 minus 2 into 10, which is equals to 0. So we cannot take a equals to 10. So instead, the only value of a that we can take is a equals to 6. So for finding b will be equals to 20 minus 2 into 6. So 20 minus 12 will be equals to 8. So a will be 6 and b will be equals to positive 8. In question 6, the diagram shows a metal plate ABCD made from two parts. The part BCD is a semicircle. The part DAB is a segment of a circle with center O and radius 10. Angle BOD is 1.2 radians. In part 1, we have to show that the radius of the semicircle is 5.646. Now to find the radius of the semicircle, we'll first find the length of BD and then divide by 2 to get the radius of the semicircle. So we can find the length BD by applying cosine rule. As OD is also 10, it is a radius. So we can apply the cosine rule by writing BD square will be equals to 10 squared plus 10 squared minus 2 into 10 into 10 cos of 1.2. Substituting this in the calculator, we'll get BD squared as equals to 127.52 centimeters. Taking the square root of 127.52, so that will be equals to 11.292 centimeters, and the radius of the semicircle will be 11.292 divided by 2. So 11.292 divided by 2 will be equals to 5.646. So this was the value that we had to prove, that the radius is equals to 5.646. In part 2, we have to find the perimeter of the plate. Now the perimeter consists of the sector of the arc length BD and the arc length BD of the semicircle. So first finding the arc length of the sector ABD. So for the perimeter, we'll find the circumference of the semicircle. So we'll find the circumference of the semicircle, which is BCD, and the arc length of the sector, which is BAD. So we have to find the arc length BD. To find the circumference, we will apply the formula 2 pi r upon 2. As we already have the radius, which is 5.646. So 2 and 2 will cancel out. So 5.646 will multiply by pi, and this value will be 17.738. So the circumference will be 17.738 centimeters. Now finding the arc length of BD. So arc length is given by the formula S is equals to R theta. So theta in this case will be this angle, the reflex angle BOD. Now as this angle is 1.2, so BOD will be, so reflex angle BOD will be 2 pi minus 1.2. So we can first write that the reflex angle BOD will be 2 pi minus 1.2. So 2 pi minus 1.2 will be equals to 5.083. So the angle is 5.083 radians. Multiplying it with the radius. So we know that the radius is 10 in the question. So the arc length will be 10 multiplied by 5.083. So multiplying this by 10, multiplying 5.083 by 10. So the arc length will be 50.83 centimeters. Now finding the total perimeter, we'll add the circumference with the arc length. So the perimeter will be equals to 50.83 plus 17.73738. Substituting this in the calculator, we get 17.738 plus 50.83. This will be 68.56. So the perimeter will be 68.56 centimeters. As we have to give our answer to three significant figures, so the final answer will be 68.6 centimeters. In part 3, we have to find the area of the metal plate. Now, the area of the metal plate will consist of the area of the sector, the area of the triangle, and then the area of the semicircle. So, for the total area, we will find the area of sector BAD. So, this will be area of sector BA, and I think this was D up here. So this is BAD. plus the area of the triangle and then the area of the semicircle. In the first step, finding the area of sector. So the area of sector is given by the formula half r squared theta. So this will be 1 upon 2 into r squared into theta. We know that the radius is 10. So this will be 1 upon 2 into 10 squared into theta, which is 2 pi minus 1.2. Substituting this in the calculator, the area for the sector will be 254.159 centimeters squared. Now finding the area of triangle. So area of the triangle will be found using the formula half AB sine C. So the two lengths are 10 and 10 and the angle between them is 1.2. So this will be 1 upon 2 into 10 into 10 into sine of 1.2. Substituting this in the calculator, the area of the triangle will be 46.602 centimeters squared. And finally, finding the area of the semicircle. So the area of the semicircle will be found using the formula pi r squared upon 2. The radius for the semicircle was 5.646. So this will become pi multiplied by 5.646 whole squared divided by 2. Substituting this in the calculator, this will be equals to 50.1 centimeters squared. Finally, for the total area, so for the total area, we'll add all the three areas of the sector, the triangle and the semicircle. So the total area will be 254.159 plus 46.602 plus 50.1 centimeters squared. So 46.602 plus 254.159 plus 50.1, that will be equals to 350.861. As we have to give our answer to three significant figures, so this will become 300, the final answer will be 351 centimeters squared for the total area of the plate. Question 7, the equation of a curve is y equals to 2 plus 3 upon 2x minus 1. In part 1, we have to obtain an expression for dy dx. So in the first step, we can write the equation as y equals to 2 plus 3 into 2x minus 1 to the power minus 1. Finding the dy dx, differentiating 2, that will become a 0. So that will be 0. Minus 1 into 3 will be minus 3. And this will be 2x minus 1. Decreasing minus 1 by 1, so that will become a minus 2. And multiplying it with the derivative of 2x minus 1, so that will be 2. Simplifying this, the dy dx will be equals to, so minus 3 times 2 will become a minus 6, and we can bring the 2x minus 1 to the power minus 2 in the denominator and write it as 2x minus 1 whole squared. So the dy dx will be minus 6 upon 2x minus 1 whole squared. In part 2, it says explain why the curve has no stationary points. So for stationary point, the dy dx is equals to 0. So if we write 0 is equals to minus 6 upon 2x minus 1 whole squared, this whole term will multiply by 0 and this will become a 0. So we can say that there are no values of x for which the dy dx is 0. So we can also write that this is not possible. So there are no stationary points on the curve. In part 3, it says at the point on the curve x equals to 2, show that the normal to the curve passes through the origin. So in the first part, you'll have to first find the equation of the normal. Now, to find the equation of the normal, we'll first have to find the gradient of the tangent. So we already have the dy dx, the value of x is 2. So first finding the dy dx when x is equals to 2, so that will be minus 6 upon 2 into 2 minus 1 whole squared. So that will be equals to minus 6 upon 3 squared, which is 9. So this will be equals to minus 2 upon 3. As dy dx gives us the gradient of the tangent, so the gradient of the tangent is minus 2 upon 3, which means that the gradient of the normal will be equals to positive 3 upon 2. Once we have the gradient of the normal, we can form the equation. As the value of x is 2, so we can substitute x equals to 2 into the equation to get the value of y. So y is equals to 2 plus 3 upon 2x minus 1. Substituting x is equals to, so this is 2 plus 3 upon 2x minus 1. Substituting x equals to 2. So y will be equals to 2 plus 3 upon 2 into 2, 4 minus 1. So this will be 2 plus 3 upon 3, 3 upon 3 is 1, so y will be 3. So once we have the coordinates of x and y coordinates are 2, 3, and the gradient is 3 upon 2, we can form the equation of the normal. So the equation will be y minus y1 is equals to m into x minus x1. So x1 will be 2. Cross multiplying, we'll get 2y minus 6 is equals to 3x minus 6. Taking minus 6 on the other side, the equation will be 2y is equals to 3x, as minus 6 plus 6 will be a 0. So y will be equals to 3 upon 2x. Now substituting, when the value of x is 0, the value of y will also be 0. So it shows that the normal to the curve passes through the origin. In part 4, it says a point moves along the curve in such a way that the x coordinate is decreasing at a constant rate of 0.06. We have to find the rate of change of y as the point passes through P. Now, the x coordinate is decreasing at a constant rate of 0.06. It means that dx by dt will be written as negative 0.06. We need to find dy by dt. So the formula relating dy by dt and dx by dt is dy by dt is equals to dy by dx multiplied by dx by dt. Now we already have the dy by dx at point P. So at P, the dy dx was equals to, as we found in the previous part, that was equals to minus 2 upon 3. So the dy dx was equals to minus 2 upon 3. Finding dy by dt, so that will be equals to, so dy by dt will be equals to minus 2 upon 3 multiplied by minus 0.06. The negative signs will cancel out. Simplifying this, the final answer will be 0.04 for the rate of change of y. In question 8a, a cyclist completes a long distance charity event across Africa. The total distance is 3,050 kilometers. He starts the event on May 1st and cycles 200 kilometers on that day. On each subsequent day, he reduces the distance cycled by 5 kilometers. In part 1, we have to find how far he will travel on May 15th. Now, as he is reducing the distance traveled by 5 kilometers, it means that it is an arithmetic progression, as is a common difference. So as it is reducing by 5 kilometers each day, it means that d will be equals to minus 5. And as we have to find the distance it travels on May 15th, so it means we have to use the nth term formula, which is a plus n minus 1 into d. As on the first day, he traveled 200 kilometers, so a will be equals to 200. So finding the 15th term, it will be 200 plus n minus 1. So that will become 15 minus 1 and d is minus 5. So minus 14 into minus 5 is 14 into minus 5 is 70. So 200 minus 70. So that will be equals to 130. So he will travel. So 200 minus 70 will be 130. So on the 15th day, he will travel 130 kilometers. In part 2, it says on what day he will finish the event. Now, as he has to cover a total distance of 3,050 kilometers, so we'll use the sum formula, which is sum of n terms is n upon 2 into 2a plus n minus 1 into d. Now, as the total sum of the distance he travels will be 3,050 kilometers, so this will be 3,050 equals to, we have to find n, so this will mean n upon 2 into 2a, a is 200, plus n minus 1 into d is minus 5. Cross multiplying, so 3,000 into 50 will become 6,100. Expanding the bracket, this will become 400 minus 5 into n is a minus 5n, and minus 1 into minus 5 is a plus 5. Simplifying the bracket, we'll get n into 400 plus 5 is 405 minus 5n, and this is equal to 6,100. Multiplying n by the bracket, we'll get 405n minus 5n squared equals to 6,100. Taking 5n squared and 405n on the left hand side, this equation will become 5n squared minus 405n plus 6,100 equals to 0. We can divide this equation by 5 and write it as n squared minus 81n, and 6,100 divided by 5, that is equals to 1220. So that will become n square minus 81 n plus 1220 equals to 0. Factorizing n squared minus 81 n plus 81 n plus 120. So factorizing this will be n minus 61 and n minus 20 equals to 0. So the two values of n will be n equals to 20 and n will be equals to 61. Now we have to decide which of these values of n to take, as both of them are giving the sum equals to 3050. But if we take 61 n as 61, in that case our terms will become negative. So as we are starting from 200, it will keep on decreasing by 5 kilometers each day. So if we take the 61st term, the value of the distance traveled will become a negative. So the value of n that we'll have to take is n equals to 20, as when n is 61, the distance traveled will become a negative. So distance traveled on that particular day will be negative. So we will not be taking n equals to 61. So this will become a negative. Now in part B, it says that a geometric progression is such that the third term is 8 times the sixth term and the sum of the first 6 terms is 31.5. We have to find the first term of the progression. Now as the third term is 8 times the sixth term, so we can first write this as, so the third term, the nth term of a geometric progression is given by ar to the power n minus 1. For the third term, the formula will be ar to the power 3 minus 1, which is equals to ar squared. And the third term is 8 times the sixth term. So for first finding the formula for sixth term, that will be ar to the power 6 minus 1, which is ar to the power 5. Now making a mathematical equation, as it says that the third term is 8 times the sixth term. So we can write this as the third term equals to 8 times the sixth term. A and A will cancel. R square will divide by, so we can take 8 on the other side. This will become 1 upon 8 is equals to r power 5 upon r squared. So this will cancel out. R cube will be equals to 1 upon 8. And now taking the cube root of 8, so the value of r will be 1 upon 2. Once we have the value of r, in part 1, we had to find the first term. So to find the value of a, it says that the sum of the first 6 terms is 31.5. Now the sum formula for n terms of a geometric progression is given by a into 1 minus r to the power n upon 1 minus r. The sum of the first 6 terms was given as 31.5. So we can write this as 2 into 31 is 62. 62 plus 1 will become 63. So this will be 63 upon 2 is equals to a into 1 minus r is 0.5. So we can write 0.5 to the power 6 divided by 1 minus 0.5. Cross multiplying, so 63 will multiply by 0.5. So this will become 63 multiplied by 0.5 divided by 2 is equals to a into 1 minus 0.5 to the power 6. So 1 minus 0.5 to the power 6, that is equals to 0.98. 984,375. So dividing it by 2 and then 63 into 0.5. So this will, the value of a will be equals to 16. Substituting this in the calculator, we can write that a will be equals to 63 into 0.5 and divided by 2 into 0.984375. So the value of a will be 16. Once you have the value of a, in part 2, it says find the sum to infinity of the progression. For sum to infinity, the formula is, so for sum to infinity, it is a upon 1 minus r. The value of a is 16 and the common ratio r was equals to 1 upon 2. So 1 minus 0.5. So 16 divided by 0.5, the sum to infinity will be equals to 32. In question 10, a function f is defined by f of x is equals to 5 minus 2 sine of x for x 0 to pi. In part 1, we have to find the range of pi. Now to find the range of pi, we can add the values of 5 and 2 and subtract them to get the minimum and maximum value. So first adding 5 and minus 2, you will get 5 minus 2, which is 3. And then subtracting 5 and minus 2, so 5 minus minus 2 will become a 7. So this will be the minimum value of f of x, and this will be the maximum value of f of x. So we can write that f of x will be greater than equals to 3 and less than equals to 7. Another way to find the range of f could have been that we could have assumed values of x as 0, pi upon 4, pi upon 2, pi and 2 pi upon 3, and then found out the maximum minimum values. And from that, we would have observed that the maximum and minimum values would have been 7 and 3. Now in part 2, we have to sketch the graph of f of x. Now to sketch the graph, we can first draw the x and the y axis. So first drawing the x and the y axis. Now, as we know that the maximum and minimum points are 3 till 7, so we can make divisions up till 7. So this is 2, this will be 4, 6, and we can label this as 8. And as the range is from 0 to pi, so we can make divisions. So let's say this will be pi upon 2. This will be pi up here. So now to make the graph of f of x, we know that the function f of x is 5 minus 2 sine of 5 minus 2 sine of 2x. Now to sketch the graph, we can assume values of x. So initially taking x equals to 0, the value of the function f of x will be, so sine of 0 is 0, so that will be equals to 5. So we can plot the first point at 0 and 5. Taking the value of x now as pi upon 2. So the value when we substitute in in the function 5 minus 2 sine of x, so the value of f of x will be, so that will become 5 minus 2, as sine of pi is, sine pi is, so this will become 2 into pi upon 2, and sine of pi will be equals to 0. So that will be sine of pi upon 2 will be also equals to 5. So this will be 5 up here, and taking the value in between, which is x equals to pi upon 4. So we can find a value at pi upon 4 as well. So when we substitute x equals to pi upon 4, so pi upon 4 multiplied by 2 will become pi upon 2, and sine of pi upon 2 or sine 90 is 1. So 5 minus 2 will be equals to 3. 5 minus 2 will be 3. So at pi upon 4, the value will be 3. So we can first join these 3 points to make the first part of the graph. And now taking the values, taking sine of pi, x value as pi, so taking x is equals to pi, the f of x will be equals to, so sine pi will be equals to sine of 2 pi is 0, so that will be equals to 5. And then taking a value between pi upon 2 and pi, so that will be 2 pi upon 3. Taking 2 pi upon 3, f of x will be equals to 7. So at 2 pi upon 3, this value will be at 7. So we'll draw a point at 7. And at pi, the value is 5. So joining these points to continue the sine graph, the graph will be made like this. So this will be the sketch of the function f of x. Now in part 4, it says that the function g is defined by g of x is 5 minus 2 sine 2x for 0 to k, where k is a constant. In part 4, it is saying state the largest value of k for which g has an inverse. Now, as g is, so we know that g of x is equals to 5 minus 2 sine of 2x for x greater than equals to 0 and less than equals to k. Now, for the function g to have an inverse, it must be a one-to-one function. So as x is starting from 0, the maximum value till where the function is one-to-one is pi upon 4. So we can say that the value of k will be equals to pi upon 4. In part 5, it says for this value of k, find an expression for g inverse. Now we already have g of x as 5 minus 2 sine of 2x. To find the inverse function, we can first write y equals to 5 minus 2 sine of 2x. Exchanging the values of x and y, this will be x equals to 5 minus 2 sine of 2y. Now making y the subject, we'll take 2 sine 2y on the left-hand side, and taking x on the right-hand side, this will become 5 minus x. Dividing it by 2, that will become 5 minus x upon 2. Now taking sine inverse, so that would be 2y will be equals to sine inverse of 5 minus x upon 2. And then finally, to find the value of y, we'll divide the whole function by 2. So that will become sine inverse of 5 minus x upon 2 divided by 2. So that will be sine inverse will be 5 minus x upon 2. And then, so the 2 had already divided. So this will be, so there will be a slight correction over here. This will become sine inverse of x was, so 2y was equals to sine inverse of 5 minus x upon 2. So that is 5 minus x upon 2, and y will be equals to sine inverse of 5 minus x upon 2, and this will divide by 2 up here. So finally, we can write that g inverse of x will be equals to 1 upon 2 into sine inverse of 5 minus x upon 2.